So this video is about Newton's laws of motion. So these laws are from the early 1600s, where Sir Isaac Newton is relating the behavior of an object in terms of its motion to the forces that are acting on it. So there are three laws. And so Newton's first law is that if the net force of an object is zero, then the object will be staying at rest or moving at a constant speed in the same direction. So Newton's first law looks like this. If the net force is zero, then the object is at rest or is moving with constant velocity. So the two important parts of Newton's first law is that if the object is at rest, then the net forces acting on the object will all add up to equal zero. Or if the object is moving with constant velocity, then the net forces of all of the forces acting on the object will also equal zero. Okay, so let's do a practice question with Newton's first law. So this will be practice question number 1. So we have a skater with a mass of 45 kilograms, and the skater is at rest. There's a second skater, so skater 2 has a mass of 50 kilograms and is moving at a constant velocity of 3.2 meters per second to the east. Then skater 3 has a mass of 75 kilograms and is moving again at a constant velocity of 9.6 meters per second, also to the east. So our question is, which skater experiences the greater net force? Okay, so with this question, we have skater number 1, and skater number 1 has a mass of 45 kilograms and is at rest. Skater number 2 has a mass of 50 kilograms, moving at a constant velocity. And skater number 3 has a mass of 75 kilograms, also moving at a constant velocity. And so every single one of these skaters is experiencing Newton's first law. So the net force acting on each of the skaters is 0. So skater number 1 is at rest, which is why F net equals 0 applies. Skater number 2 moving at a constant velocity in one direction, so F net equals 0 applies. And then skater number 3 also moving at a constant velocity in one direction, also is going to experience Newton's first law, so F net equals 0. All right. So the nice thing about using Newton's first law is that this is going to apply in any situation where the object is either not moving at all or is not moving with any acceleration. So it's moving at a constant velocity. So anytime we are dealing with an object that is at rest, Newton's first law applies. Anytime that we're dealing with an object that is moving at a constant velocity, Newton's first law applies. So that's Newton's first law. Usually the one that we're going to try and use first, that's why it's Newton's first law. And then now we're going to talk about Newton's second law. So Newton's second law so Newton's second law is going to apply if Newton's first law does not apply. So in those situations, that means that the object is speeding up, so accelerating, or the object is slowing down, which we know is also accelerating, or the object is changing direction. Okay, so Newton's second law is that the net force acting on an object is equal to the mass times the acceleration of the object. So in this equation, our M stands for mass, which of course is measured in kilograms. And then our A stands for acceleration, which is measured in meters per second squared. Okay, just like we normally measure acceleration. So if Newton's first law does not apply, then Newton's second law applies. So if the object is not at rest or not moving at a constant velocity, then we're dealing with Newton's second law. So we're speeding up, we're slowing down, we're changing direction. Okay, in this case, the net forces will not cancel each other out. So we will not have a net force of 0. We'll have a net force that is equal to the mass of whatever object we're looking at times the acceleration. So how fast it's speeding up or slowing down or changing direction by. All right, so we're going to do a couple of quick practice questions with Newton's second law. So this one is practice number 1 with Newton's second law. So we have a net force of 126 newtons to the south applied to a 70 kilogram sprinter. Both start with an S. So we're going to determine the acceleration. Of the sprinter. Or squirrel, if you want this question to be a squirrel. All right, so we have this net force of 126 newtons. It's not 0, so we know that we're not dealing with Newton's first law, we're dealing with Newton's second law. So our F net is 126 newtons. And the mass of our sprinter is 70 kilograms. And we're trying to find the acceleration. So we're going to use the fact that our F net is equal to mass times acceleration. So our 126 newtons is equal to our 70 kilograms times our acceleration. So then when we rearrange, we're going to have our acceleration of 1.8 meters per second squared. And we're going to be going in the south direction. So we're 1.8 meters per second squared. And we're still traveling south because that was the direction of the net force. Okay, we're going to stop there and we're going to pick up in video number 2 with another couple of practice questions as well as Newton's third law.